Okay, for these questions, we're going to use proportionality to solve for force. So we have our equation, force of gravity is g_mm over r squared. Sometimes you don't necessarily need to re-plug in everything over and over again. So what I mean by that is, just say we had the Earth and you have someone on the Earth. Then you have someone that's also like twice as massive. So if you know that if the person's mass were to just double, the force would double. So if for example, if the person had a weight of 1,000 newtons, if someone was twice as massive, they'd have a weight of 2,000 newtons. So we can do that. We can figure that out by looking at the equation. So first one, force of gravity is equal to g_mm over r squared. But right now we're just thinking, how is Fg related to little m? So force of gravity is proportional to m. So if m were to double, if the right side were to double, the left side has to double as well. So it's going to be 2 times the force. If our distance is 2 times larger, we can see over this time we're only going to look at how F and R are related to each other. So 1 over r squared. So if I were to replace that r with a 2, because it's 2 squared, we get 1 over 4. So it's going to be 4 times smaller. If big M were to get 4 times smaller, the force would also be 4 times smaller. If the distance is 4 times smaller, you get 1 over r squared again. If I replace that r with 1 over 4, again, r is being squared, so you get 1 over 16 when I square it. So 1 over 1/16 is equal to 16. So it's 16 times more massive the force. For the last one, force of gravity, we can work with more than one variable at a time. Like for example, if big M, little m, and r is all being changed. So we can say, okay, m is being halved, big M. Little m is being tripled. D is being halved, or r is being squared. So you get 1/2 times 3, 1.5, divided by a quarter, you get 6.